Hi, my name's Tom. Welcome to another Rust programming livestream. Today we're doing more work on my programming language and virtual machine. I've recently undertaken a very large branch where I've introduced optimizations to my compiled programming language that targets my virtual machine, and I've realized that there's a couple of problems with my instruction set. So today we're going to jump in, we're going to write a separate parallel branch of work that fixes some of those problems, changes the instruction set. Then we're going to rebase my optimizations on top of that and make any changes we need to make, clean it up so it looks nice. And I want this, like, this is a good way to work in general, I think. I don't want to merge changes in just to have to like redo a bunch of stuff with them. It'll be much better for the commit history if I make my ISA changes first and then merge stuff in. This register optimization work has been really long running. I think it probably started about a month ago, maybe a little bit more even, and it's been on and off, and it's been really hard, and I've diverted through some other projects, but I've got this working in the background for the first time since I started working on it, and this doesn't look very impressive, but I can run cargo, if I can type, I can run cargo T, and all my tests pass. Timber Theta Delta, welcome. Yeah, we're doing ISA stuff. I know this is your kind of territory. The big thing is, okay, if we go into my opcode definitions, right, my operation definitions, one of the concessions I made, right, because I really liked RISC-like design. So if I look at, and let me just add some pages here. Let me get rid of that. Let me just make some new transparent layers and move my title underneath it. Okay, here we go. So one of the concessions I made, because we're at 16-bit VM, so VM, let's zoom in a little more, let's 16-bit VM, okay? So each instruction is only 16 bits, and 3 bits of that is the register selector. So in other words, 8 registers. One of those is the 0 register. We might get rid of the 0 register. I think when you only have 8 registers, having a 0 register might be a bit excessive. If you're like RISC 5 and you have 32 or like a lot of registers, then maybe having a 0 register makes sense. But if you have 8 registers, I don't know if having a 0 register makes sense. Especially when one of those registers is going to be your stack pointer. Okay, so how do we allocate these out? So we have a stack pointer, we have a base pointer, because we like having stack frames. You can do it without a base pointer, but I like doing it with a base pointer. I think it's cleaner. I think it's less code. So we're going to have a base pointer for now. This is the next thing on the chopping block. But one of the things I also have as a register that we're going to get rid of today is the program counter. I thought it would be cute if the program counter was just a normal register. That means that instead of having a jump instruction, you can just say load an immediate into the program counter, load 4. You jump to address 4. That's cute, right? And if you want to do a branch, you just add an immediate to the program counter. Add in PC 7, right? Probably not 7 actually, it should be a multiple of 2. Jump 4 instructions into the future, because each instruction's 2 bytes. So this was a cute idea. This felt very risky, but risky in the sense of risk. Reduced instruction set C. I don't know what C stands for. Reduced instruction set, right? So this felt like a good idea. But then I started doing stuff with the virtual machine and I was like, man, it kind of sucks that we only have so few registers to work with. The way that I've done register allocation for my language, you kind of always need 2 temporary registers to juggle stuff around with. So you have these 3, you have a 0 register here. So that leaves you 4 registers, and if you need 2 temporary registers, that means you only have 2 registers left over to do work in. So of these 4 remaining registers, right, A, B, C, and M, we've marked off C and M as temporaries, which means we only have 2 general purpose registers left that can be used for actual optimization. That kind of sucks. It means we do a lot of stuff on the stack. The other interesting thing about this is it's actually not enough registers, because in theory, we should have a page selector sometimes. This is 1 register. It's supposed to be the M register, M for memory. So this is a bit of a problem. We don't have enough registers. So we're going to get rid of the PC register. We might also get rid of the 0 register in the future, but the PC register first. If we want to later, we can get rid of 0, and then if we really want to later, we can get rid of BP as well, because you don't technically need a base pointer. It makes things easier, but we don't need to. So we're going to get rid of PC. And to get rid of PC, that means we can't jump and branch by doing this anymore. So we're going to need to write new instructions. We're going to need to write jump n and branch n by an immediate. We could also do branch reg, where we branch according to a register. That's kind of cool. Where we have some like register, and then probably also room for an offset from that register as well. Maybe that might be fun. The other thing is, actually no, that's it. We also use addif, right? We use addif a little bit. So let me pull up my decompiler. Let me pull up my disassembler, okay? So if I just compile whatever I have in my example file, cargo run bin lang test2, so we can compile whatever code I have, and this is a binary. And we can load that binary into my tool, but first we have to encode it. Base 64 URL. Base 65 sounds cool, but I haven't invented that yet. Base 64 URL. Xclip selection C. Okay, so now we can paste this in to my little tool, and we can view the binary. Now, when we do a branch, do I do any branches here? Addif, yeah, we have an addif, and we addif to the program counter, and that doesn't work anymore. So one of the things we do with a branch, okay, one of the things, the way we currently branch is with this addif instruction, and addif adds something to a register if the flag is set from the test instruction. So you always get this test addif pair. And now we don't get that anymore. So branch should maybe only branch if the test flag is set. That would make sense to me. I don't know if that makes for clear code, but maybe we need a branch and a branch if, but also jump is going to have a really big range. So let's try doing it. Let's call the instruction branch if and branch reg if, and we won't have a normal branch. We'll only have branch if. And that'll be where we start. If we need to later, we could add branch non-if, or we could add an instruction. I mean, I guess the thing is, if it's a unconditional branch, if you always branch, you could just set the test flag to true. You could say test that 0 is equal to 0. And actually, there's a few of our instructions that really rely on having a 0 register, so maybe we can't get rid of a 0 register. Maybe this is actually baked in, because our test instruction, there's a lot of cases where we might want to use the 0 register for that comparison. And it'd be a lot of thrashing to load 0 into a register just to do that. It'd kind of mess some things up, I think. So yeah, instruction to set flag, exactly. Well, you don't need an instruction to set the flag, right? You don't need an instruction to set the flag, because you can just test 0 equal to 0, right? Or, you know, that's the kind of idea, right? We're RISC. We don't have one-off instructions. We have general instructions that do a lot of different things and that have lots of utility. Fewer instructions. We only have this many. We only have... Am I out of... Hold on. How many bits do I have for opcodes? Am I out of instructions? 1, 2, 3, 4, 5, 6, 1E, 7, 8, 9, A, B, C, D, E, F, 1, 0, 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, 1... Okay, so we have 1, 6, 1, 7, 1, 8, 1, 9, 1 A, 1 B. We've got like 8 instructions left that we can add before we run out of encoding space. That's good to know. 16 through 1D. What do you mean 16 through 1D? Oh, yes. Yeah. It's not quite. It's 1/6. Yes, hex 1/6 through 1. Yeah. Sorry, I read that as the number 16, which is really silly. It's always hard. Base yeah, you're correct. So 6, 7, 8, 9, A, B, C. So we have 7 instructions left in this space. And that's enough. That's enough to add some stuff. I don't need to be precious about this remaining space. So let's add some stuff. Let's add one called branch if, and this instruction is going to take, it's going to be a big one, right? So what's another, it's going to just take a literal, no, can we do that? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oh, there goes my light. That was a nice idea while it lasted. Literal 10? Do we have literal 10-bit? We have a literal 10-bit. I don't think I use it currently. We have a literal 10-bit. We know how to encode this. So branch if. Oh no, sorry. So let's do jump first. Unconditional jump. Always jump somewhere. Then we'll say branch if, and this is a relative, right? This is where we add this. Just do add an instruction that's a prefix. No. We're risk. Even with a slash joking, right? Variable length instructions, I hate them so much. Ever since I learned, because I always thought x86 was really confusing and weird, and then I learnt risk, and I was like, oh, it doesn't have to be this way, right? I did a uni course on RISC V, and then I've done a bunch of PS2 stuff as well, and I'm like, wow, this is really good. This is really good. That's not even half the madness of x86, right? It's not just a prefix instruction. It's like, it's everything. It's everything. Okay, so branch if, and then we'll also say branch if, branch reg if. And this will take a register and a literal 7-bit. Beautiful. Cool. And we can get this out as signed, which is what we're going to do here. So if I build this right now, we're going to get errors, and that's good. We're going to get errors because when we implement instructions, we've got some things that we haven't covered. So this is great. You know, this is all defined in a macro as well. So this VM instruction macro, this actually automatically defines the encoding and decoding of these ops. Because these are types that we know and we've worked before, and it's just part of how my ASA works, as long as we use these types, you know, and we have to be explicit. We're like, hey, this thing is a 10-bit literal as part of my instruction. My macro knows how to fit that all into an instruction for encoding and decoding and printing out as a string and parsing from a string. So we get all that for free here, which is really nice. It's really useful for extending my instruction set. Danilov Code, thank you very much for following. Welcome. Feel free to say hello. Feel free to introduce yourself. I love to hear what people are working on, what's going on. You know, what brings you to a Rust programming VM stream? Are you a Rust person? I love meeting Rust people and hearing about what they're doing. Very, very cool language. Okay, so if we go to vm.rs, we can find where this is implemented. Match op, and we want to add, and we'll put it, I guess, down the bottom, maybe before system. We'll go instruction. We want jump, branch if, and branch if reg. Jump, adder. Now, we need to think about this a little. Nate Shed. What am I doing? Welcome. Sorry for butchering your name. Names are hard. What am I doing? I am currently refactoring my instruction set for my virtual machine to support actual proper jump instructions, because previously my program counter was a register and it was taking up too much register space. It was cute, it was a fun idea, but we're making program counter a special thing, and then we'll just gain a general purpose register, which is very good because I'm trying to optimize my programming language compiler targeting this VM to use registers in a smarter way. We didn't have enough registers to really make that worthwhile. Okay, so jump to an address. Now, the only thing we need to consider here is how do we jump to things outside of this range? Can we only jump to the first 10 bits of our 32-bit address space? Perhaps. Maybe that's acceptable for now, but it's a little bit limiting. Maybe we don't want jumps to be relative because that sucks for a different reason. Now, the way we did this before, right? We used immediates, which are 12 bits, which isn't much more of your address space, but it's kind of significantly more. So maybe, and it's kind of hard, maybe we need to have like a jump page or something, I don't know. Or maybe we can only jump to addresses that are multiples of 4, and then it's kind of like we're dealing with 14 bits, right? Like multiples of 4, like we add multiples of 16, then it's like we're dealing with 14 bits. So there's ways we can do it. There's ways we can think about this. Let's do that actually. Let's do a bit shift. And let's say code, like things we jump to have to be aligned to a certain point. We can branch in a smaller relative range. This is a sensible thing. I think MIPS does this. I assume RISC-V does it as well. I can't quite remember. I've dealt with MIPS3 assembly more recently because I was writing code for the PlayStation 2. So let's let target equals adder dot value dot get as a number. What's my API for this? What's my API for literal 10-bit? From signed dot, it's just dot value, And then I want to left shift that by 4. Addresses that equal, sorry, my layer keys on this keyboard aren't working properly, so I keep typing Ks when I mean equals. Something that equals 0 mod 16. Left shifting address by 4. This means we can jump to a much bigger range, and that's good. That makes it more useful. All we do is a self.program counter equals target. Okay. I think that's what we do. Now, the other thing is, we need to actually add a program counter now. And let's make it a U32. Let's say our program counter can point anywhere in our address space. Does that make sense? Maybe it's reasonable to say our program counter can only point at our 0 page, but I think it's more fun, in theory, to say it could be a full U32. I don't hate the idea of... Because we have 16-bit registers, so we can address within a 16-bit page really easily, but if we want to address outside that, we need to do some like paging. We need to think about long pointers. Dinkleman says, nice haircut, thank you so much. I feel very fresh, I feel very clean. I've told this story a few times now, but I saw an Iraqi barber. He was a really cool guy, he had this thick accent, and he was like, I was like, look, I need help, I'm going bald, I've got long hair, it's not looking good anymore, and he was like, I've got you covered. He was like, how long have you had long hair? And I was like, oh, it's been about 3 years. And he's like, 3 years? You've had a good run. Snip, 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 snip. Like it was gone. And like I didn't have time to think about it. I didn't have time to change my mind. And I'm really glad he did it because it's looking great. He's cutting my hair. He's like, this is a good look for you, my friend. He was a hype man. I loved it. I'm exclusively going to go get my hair cut from him now. He's made a customer for life. Yeah, Dinkelman, how are you going? What have you been working on? What's been going on? What have you been building? I wrote a really cringe LinkedIn post the other day because I've decided I'm probably going to just apply for full-time jobs again because I'm not making enough money dicking around teaching, which is fun. It's probably time. I've had a nice little holiday. I've played lots of music. Maybe I just need to be sensible again. Program counter. We should probably... Like, if I was more sensible, I would do the program counter bit before I added the instructions. And I'm actually just going to do that. I'm going to do this in one commit first, where I add just a program counter. This makes more sense. So everywhere we have register PC, we'll keep that for now. Now this is interesting. So we probably want a function because we have this flag that says if we just jumped. We don't use it, but I think it's a good idea in general to have a flag that says if you just jumped. So we're just gonna pub fn set PC, right? We'll have a mutator for setting the program counter, and it'll just have a value, which is going to be a adder, which is a U32. And then we're gonna do this, right? Set flag. And then we say self.program counter equals adder. And maybe we'll call it set program counter because it's better to be a little bit too verbose. How to encourage your health is too shit to make it worth by applying for anything. Working on some personal stuff, messing around with migrating computers to Nix, writing a game add-on, nice. Bit of a roadblock. You chained HTTP requests, oh dear. Oh dear, that sounds rough. I'm sorry to hear about your health. That's always hard. But it's good you can go on with some personal projects while you're doing it. Migrating everything to Nix is cool. That's something I've wanted to investigate. I've got a friend who's in the middle of it, and it sounds really, really good. Do I have a public repo for this project? Yes. Tombot is on it. I need to set up a bot that links this when people ask, but for now, you get the manual version, which is cool. right? I hope you appreciate the bespoke link sharing effort. Be warned, there are no comments. There are tests, but there are no comments. You know, and I've always adhered to the philosophy that tests should serve as comments. So I guess that's okay. Nix has been great. The only complaint is the documentation. I'm loving Arch documentation so much that I'm scared to change to Nix, you know? Like, it's a curiosity, but I think Arch is just so rock solid for me that it's hard to convince myself I should change. I want to buy a server, a home server with a bunch of hard drives and stuff, and I want to set it up with FreeBSD maybe, and I thought that would be a fun live stream, because my capture card will be here next week, so maybe I like HDMI my server into my capture card and do all the setup live. That would be cool. I just need the money to get all the stuff, which is why I want a job. Awesome. So, program counter. Maybe we should have get program counter as well. It can't hurt to have a public function for this, because especially when we integrate the machine in other things, we'll say get program counter, except this one just takes a ref to self that isn't mutable, and all we do is return self.program counter. It gives back a, we'll make it a U32. I think bake in a U32 from the start. Arch documentation is universal for any distro. Yeah, Nix is different. It works. It can be hard if you need to set it somehow. Yeah, you need to set it up somehow first. There's like a weird bootstrap set. And yeah, if things don't work, like ArchWiki is not going to be as helpful. ArchWiki, incredible tool, incredible tool. Okay, so instead of get register, now we say self.get program counter. We read that address. Now we don't have to cast that to a U32. It is a U32. That's good. I like that. I like fewer things, This all works the same way. That's actually a really minor change. So if did jump, if we didn't jump, we increment the program counter. Yeah, that makes sense. Because if we jump, if we move the program counter, we don't want to advance to the next program counter. We only do that if we haven't jumped to another thing. So we'll say self.program counter plus equals 2, and we set the jump flag to false. Did jump is only useful internally, I guess. I'm not sure if this is the right way to communicate this, but anyway, it's kind of interesting. So this is good. Let's go back into our ops file and let's just quietly comment these out. Cargo B, cargo T. Is this going to work if I test? No, because we're not generating code that understands this. Because program counter is no longer a special register. We're not doing anything with it anymore. Okay, so vm.rs. There's more work to do here, and it's good to pull this out first. It's really, really good to pull this out first. So register PC. We'll call it PC. We'll keep it called register PC for now. grep RNI register PC, and we just want to look in VM source for now. Bin VM. So we need to change this. VMRS. What's this? 114. That is fine. We're happy with that. 51. Register. So register shouldn't have any behavior that's specific to the program counter. It's just going to do all this encoding and decoding, and we're still just going to call it PC for now. I think eventually we're going to call it D or something, right? A, B, C, D, M, SP, BP. PC will just disappear. That's cool. That'd be really nice. But for now, that's okay. We don't care about that. And WASM, that's also fine. So cargo T P VM. VM. How do I just test the VM? Cargo T help. I just want to run one package. P dash package, yeah. So it should be T P VM. Why can't I do this? P lame. See, that works, but that doesn't. Huh? members VM. Why can't it find VM? Is VM a special name? Cool. Okay, well that's great. I can't just run my VM tests. But that's fine, because we should fix the language as well. There should be one commit. So let's fix the binary first. VM bin VM set set register PC. Okay, so what do we do now? We say VM set program counter bin entry point. Perfect. That's it. Easy. And this has an extra layer around it for some reason. Why does this have an extra wrapper? How did I end up here? VM binary file from bytes VM machine. Where does machine come from? Oh, it's not obvious, is it? Machine vm.rs machine. Oh, and I wrapped all these things up, so that's okay. We say pub fn set program counter. This indirection has a purpose in the borrow checker, but it's ugly, and it's probably not the correct solution. So that's okay. That's okay. Set program counter adder u32. We just say self.vm.set program counter adder. We did the same thing with get, except the u32 goes on the outside, and it's not a mutable ref, it's just a normal ref, and we just say return get program counter. Beautiful. Okay, so now we should be able to run this. Get program counter is a function. I somehow forgot. Set program counter cannot convert u16 into a u32. That's okay, because yeah, in our binary we only allow a 16-bit entry point, but that's fine. We can just into this. I think in the VM API having a 32-bit program counter is wise. I think it's very future-proof. Binary formats can change, but the actual VM APIs, they're a bit more set in stone. Said no one ever. Cool. That's okay. My binaries are versioned, so worst case, I can always, I can still use old ones that have 16-bit entry points. Maybe your entry point has to be in the 0 page, that's okay. The program counter can be anywhere, but you have to enter in the 0 page. That's also a reasonable thing to enforce as well. Cool, so that builds, and it does nothing, because there's nothing to do. So what if I cargo R? This is still not going to work, but that's okay. We can pipe a program into it like this. And I don't know what happened, and that's okay. That's also okay. Cool. Cool. Okay. We'll roll with that. We'll roll with that. Nice. Nice. Oh yeah, I have an output device mapped into this. I forgot. This funny old address. Okay, that's good to know. That's good to know. So we can manipulate the program counter now, and it's no longer a special register. Let's go into, so let's rerun these tests. Let's rerun these tests. Make T. Now it's going to be a lot of failures. Now a lot of things blow up and yell at me because none of them do anything. 0 instruction. Program counter 2. Yeah, that's good. That's really good. VM tests common. So we don't do anything with the program counter here, but lang tests common. We do set the program counter. So now instead of this, it's going to be VM set program counter register. Not register PC. It's just bin.entryPoint.into. Do we have anything else special with the PC? No. So that is a step in the right direction. It's still going to be wrong. It still fails. But at least it fails in a different way. Now when we have code where we say, where we try and branch, we just don't branch. So because the way my code gets compiled, the entry point's there, you go down through some instructions, then you jump to main, and then main returns, and that's where the system halt handler lives, right after where main returns to. So if we don't branch, and if we don't jump to main, then we never get back there. So that's cool. The other thing is functions have to be aligned to certain addresses now. This is a change. And actually, maybe this is a change I shouldn't... I think it's okay to say that functions should be 16 byte aligned. I don't think that's ridiculous. I don't think that's particularly strange. I just need to make a change in my compiler. Code gen, maybe? Top level? Because this decides where functions go. For each function, program offset. Offsets, insert, program offset. Yes, okay. So, this is good. Before we add an offset, we need to let's define name offset context. Do we respect the offsets when we concatenate everything together? I assume we do. I assume this will pad everything out the way we expect. It's possible that it won't, but I assume we will. Let's try it. Let's try it. So while program offset mod 16, thank you, is not 0, program offset plus equals 1. So increment it till, like, pad our functions out until they align with 16 bytes. Very important, very important. Now, the other thing we need to look at is in PC. Ah, yes, that is actually, in fact, here. I forgot we hard-coded that. Bugger. This is in a function call. Yeah, this is the end of a function call. Oh, okay. That's okay. So, we can't do this. We just don't have the instructions to do this anymore, I guess. And that's okay. So we need to add the instructions. This is where we do it. I don't know if this is worth committing in parts, actually, because if we look at our diff, right, we have this in the virtual machine, but I guess we can commit the VM part of this first. So let's add VM. Whoa, hold on. Git restore staged VM. Okay, hold on. I forgot what I was doing for a second. Git checkout. Let's git stash. We're going to check out main, because my point was to rebase my optimization changes on top of this. So this should come first. So I don't want to commit this on top of what I'm already doing. I want to check out main. I want to check out a new branch called PC instruction, I guess. Now I want to git stash pop. And now can I cargo bin VM? Can I build it? Yeah. Can I build the compiler? Yeah, that's good. That means it didn't break anything too bad. This is still here. So that's nice. That's really good to know. So now we can start committing stuff. Okay, cargo format as well. Okay, so what did we do? Add program counter field not register. Excellent. And it's actually kind of good that we can run our tests and see that they fail in a really predictable way, where they just run through to the end immediately, because that means that our program counter is actually working. It's actually counting the program. It's not counting correctly. It's not doing the right thing. We're not branching, but that is actually surprisingly decent. This would be nice to test, but I don't know how we test it necessarily. I guess I could build a binary. Okay, what about this? What if I cargo run bin lang test .code basync URL xclip selection C. And we panicked. Why did we panic? I guess because we did something complicated. Okay, so maybe my... Wait. But main shouldn't have that. What the hell's in main right now? What am I... What? Huh? Codegen expression. (419). Oh, it needs 2 temp registers. Yeah, sorry, this is a to-do. So this is very similar to the error that we actually added once we are doing registers. No, we have this. So, did I do some of this but leave it broken? What did I merge? What am I doing? What is going on here? That's okay. Oh, hold on. I actually need to check this. I actually really need to check this. It's also possible this is just like commits ahead of main. Tokenize functions a little. Yeah, no, this does not have any. Doesn't have any of it. Okay. So, git log register hash, register state. Okay, so we have 3 commits that do not belong here. What do we do when we have commits that don't belong in a branch? How do we clean them up? We want to be working on top of, we want these 3 to disappear. So let's do it. So make register hash, register. Okay. Git rebase I head 5. We're going to stash what we have in flight, and then we're going to rebase. And we're just going to drop a couple of functions. So tokenize the functions a little. So we want to get rid of these 3 commits. Okay, beautiful, beautiful. Now, does this have any conflicts? No, still surprisingly easy to merge. Okay, so what if I build this now? It blows up in a different way. Because I misspelled a thing. Nice. Okay, well that's good, that's good. Let's put the binary in here, and let's see if it's padded. Okay, it's not padded. 242. 136. So where are our starts of functions? Where are our starts of functions in here? It'd be nice if I had more debugging info, but we've got to find them ourselves. And you can always find them because the first thing it does is... It's always really easy to find them because the first thing that it does is... It's always really, really easy. It's not this, not this. It always adds to the stack pointer. If you see code that adds 0 to the stack pointer, that's the start of a function. Because my functions are dumb. They can't work out not to do that, not to omit that. PC 0, okay, so this is a long function. I think I've gone past one. Surely I've gone past one. Push pop 0 stack PC stack sp pop. 0. Oh, add im sp4. That's the one. Sorry, add im sp. Okay, so here's the start of a function, 236. Ah, yes. Okay, so 236. 236 divided by 16 is not 0. So 238, 242, 236. 14 point, right, 236. Okay, 240. So do I find MPC 240? No, I find 242, which is also not a multiple of 16. It feels like we might be off by 2. Thank you, Temper Theta Delta. Doing maths on camera is hard. I don't know if people have found this, if other people who stream are like, man. So what if I find another function, add msp, 286. Let's go, so 286 divided by 16, 17.85. So we would expect this to be, yeah, 288. But I'm gonna guess we'll have MPC 290. Or neither. That's also fine. $48, 320, 256, 48, 320, 268. Okay, so that was like a fake function. What about 96? Where's 96? There's one, it'll probably be a little before 96. It'll probably be 96. We've got to be careful, not all of these are function calls actually. This one is this one is, because we're setting the base pointer to the stack pointer, so that is a function call. So where's function 96? Add m, store word, stack 96, load word, add m signed, add blah 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 blah, add m. Oh, here, literally right here, 96. Is that 78? No, that misses an entire multiple of 16. That misses, and of course it does, that misses 80. 80. But we jump straight to 96. Okay, that's a bug. That's a bug. And that's a good bug. So what happens? So we define all this stuff and we hand back a context. A context has stuff in it. That's function definitions. Function definitions have offsets. Function definitions, no, that's a function, no, hold on. It's symbols, function definitions, global state, data. Where do they go? Register labels, offsets. Ah, yeah, that's not where they actually go. Functions, block size, insert, block. For each block, context functions. Oh yeah, block. Okay, we have the blocks. And does a block have an offset? A block should probably have an offset. I mean, correcting the offset, not putting any instructions. The instructions are already there. The instructions are already in the block. This is a later pass. Like the last pass is the allocation of functions. We've already compiled all the code at this point, but we haven't resolved. We've compiled all the code, but we have unresolved symbols that reference things like function calls. So this is like the final step in the compiler. Do all these things. Now I think block is in compile block, obviously. Block, where is block? Block has an offset. And I don't think block offset is currently used. Maybe it is. Offset. That's a different offset. Block, local offset. Offset, software gets type, to binary. Okay, here we go. Instructions. Soft.get instructions. So what is get instructions? Aha. For each function instructions, add them to the thing. Okay, so this is a problem. Here we have a problem because this just gives back a vec of instructions. It can't deal with padding. It's not smart enough to deal with padding. So maybe get instructions should give back like a vec of offset instructions, and then it doesn't matter the order we iterate over functions in, because that's kind of important right now. Right now it assumes we iterate over functions in the order that they appear. Maybe we actually need to give back a U32 instruction, like an offset in memory, and no, hold on, that's backwards. We need to give back a U32 offset and the instructions that go there. Maybe there should be a type. I have an op instruction pad the vec with that. Yeah, but I would have to keep track of where I was, and that's silly. It makes more sense to let the step above this do the padding, and to just tell it what the offset for each block of instructions in, because this function currently does too much. It shouldn't really have to, like, we're not giving back a list of instructions if we have padding as well, right? I guess that's kind of the thing. I think it makes more sense, because some of this padding could be quite large. We don't really know. It makes more sense for the thing calling get instructions to be able to make that decision itself. I think giving back... Wait, no, that doesn't work either, though. It needs to be a vec of this. A vec of this. Which, I don't know, maybe this is too silly. If we... These aren't sorted. There's no guarantee that these actually stay in the order that I say they are, right? We shouldn't rely on iteration order to be the order in memory that the functions are laid out. That feels kind of silly. And so once I start writing code to check the offset of each of these functions, that really brings that ugly fact to the fore. And I would rather not tackle that. So I think it makes more sense to give back a list, but that's also kind of stupid. This is an ugly type. I'm just gonna do it. I'm just gonna see how it looks. We can always roll it back. We can always roll it back. So out is a vec, which is good. And symbols, resolve symbols, and that's good. That's good. This is good. This is good. This is good. We resolve all of our symbols, and we push C. So C is a list of instructions. Push C. C, resolve, instructions, ins, function instructions. Function for func block resolve, ins resolve, ins in function dot, sorry, in dot instructions, avec unresolved instructions. For each instruction, we resolve it and we push it to the output. So now what we do instead of this is we say let mut, we want a mutable vector of function instructions. This is inefficient, but understandable. And then we say function instructions push, and then at the end of this loop, we say out.push the offset of the block, which is func.offset, and function instructions. And I should probably use a map or something for this. I feel like there's a way to do it that would probably be smarter, but that's okay. We'll live. We'll live. We'll live with it not being perfectly smart for now. Okay, that's good. That's good. Now if I build this, it's going to yell at me for a bunch of stuff. Context. Method not found. Good. To binary. So this is nice. I forgot because a bunch of things were calling two instructions before, and now just one thing calls it. The context knows how to turn itself into a binary file. This was a good thing. This means that we don't have to deal with a bunch of different consumers of this anymore. Now get instructions. Let's rename this. Let's call this function offsets equals this. Now code bytes extend from slice. This is good. This is good. Because this means that, So now this sorting feels like it would be more important. So now maybe this is where we sort it, right? Functions and offsets. We're gonna give it a really bad descriptive name. Code bytes. Okay, so now we want to sort this, and I'm sure Rust has a good way of doing it. Rust must have a good way of doing it. How to sort a vector. Sort. Excellent. Does a tuple have an ordering? Hopefully. We'll find out. So we should just be able to call sort, and it mutates it. .mapr, and we question mark it, so we should then be able to say sort. And we'll find out what that gives us, but I sure hope it is things sorted by the first element in the tuple. Rust tuple. Let me see if ord. Partial ord? Partial ord. arity of 12 or less, that's okay. How is partial ORed up to 12 items long? But how is it done? How is it defined? Lexical ORed. Okay, well, we'll find out. We'll find out. This may not work. I may need to have my own thing, my own comparator. So for offset func, for offset instructions in function and offsets, and I need to rename this to functions and offsets, right? So we have where it should go and how many bytes it is. Is there a way to copy elements into a slice? More instruction, extend from slice. I want like extend from slice. I want like insert from slice, right? I want to give it an index in the slice. So one strategy here, I guess, would be to make sure that the vector, the bytes vector, we'll call it bytes. Currently it starts empty, and then every function appends to it, right? So it adds, you know, some stuff, and then the next one appends more stuff, and it grows this big long vector. And that's okay. Maybe now a smarter way would be to pre-allocate the entire vector and then put each function at its appropriate offset inside of it. This was a side quest I wasn't ready for, but I think this is good. I think this is good. And then it just gets padded with zeros, which is an op anyway. I think that's okay. We'll find out pretty soon. Also, the offset isn't being calculated correctly, but that's like, you know, we can cross that bridge when we get to it as well. Cool. Part of my nail just, like I had a coating on my nail, just chipped off. That's fun. It's very distracting when I'm trying to talk. So I guess one thing I could do this in two passes, right? I could try and calculate the max, max code. And then I say, max offset and max offset func size, because each instruction in this point is 2 bytes. 2 bytes. So we could say if offset is bigger than max offset, we'll make max offset -1. So then everything should be bigger than it because it's unsigned. Hold on, I'm not in the right scene. So we'll do this. We'll have a max offset func size. We'll have a max offset. If our offset's bigger than our max offset, which should happen at least once if we have one thing or more, we are going to say, we say max offset equals offset, and we say max offset func size equals instructions len. How many instructions we have times 2. Times 2. Because each instruction is 2 bytes. Okay, so we do this first pass, and then we say, cool, we did it. Congratulations, we pat ourselves on the back. Okay? We've looped over a thing, and we've worked out how big our code bytes need to be. So we probably say something like code bytes. We define it down here. We say code bytes. Now, how do we allocate a vec with size? Allocator capacity? With capacity. That's good. That makes sense. With capacity. Okay? And what we want to work out is the max offset plus the max offset func size. That's the biggest number we're going to need, right? The function that's furthest out in memory plus however much of an offset it has. Awesome. Awesome. And in theory, if we had a really big gap, we could have different sections and stuff, but my compiler isn't smart enough for that right now. It does support sections. We just put all our code in one section, even if there are big gaps. Because who would put big gaps? You know, that's weird. That'd be pretty weird. Now, for this, we need to just add this extra step. So instead of just iterating over our instructions, we iterate over each offset instructions. Then we say for I in instructions.iter. I need to make sure this doesn't move this, but I think that's okay. I think that's fine. You can iterate over something twice. As long as you don't move. As long as you don't move. Might need a borrow in there somewhere. Let raw instruction. Maybe we'll call it index ins, because we're gonna say enumerate on this iterator. That's pretty cool. Now we get an now we get an index as well. So raw instruction, which is a u16, is i.encode u16. And we get this is that thing we got for free when we added instructions to our ISA earlier. Cool, so we have a raw instruction. We have a raw instruction. What do we do with the raw instruction? We have to put it somewhere. So we say code bytes dot. Now I want like an insert from slice. Can I do that? So we have extend from slice. Can I say insert from insert element t? Insert into raw parts. Insert. I guess I could do this in 2 parts, but I don't want to. No, okay, well no, let's do it. Let's do it. Let's encode this and then 2 LE bytes, where we get a slice. So we'll say code bytes offset plus I equals raw instruction 0, and then this +1 is this +1. The 2 bytes go into our code. This is probably going to break all sorts of stuff, but let's try it. Let's try it. What happens if we run it right now? It yells at me. Of course it does. Functions and offsets is not an iterator. Neg is not implemented for usize. That's good. Okay, so we've got some stuff to fix. We've got some stuff to fix. Index ins. Yep, that makes sense. This has to be we're destructing a tuple. We need brackets. Good. What's next? Sort. Ord is not satisfied. Okay, so can we sort Rust sort on lambda? Can we give it like a thing? Sort by. That's the one where we're going to give it a function. Nice. We can do that. We can do that. Sort by. We're going to say lambda. We'll have an A and a B. And actually, each of these things are going to be, we'll call it A. I think we can destruct nested like this, because all we're going to do is say A.cmp B. We'll do that. And I think that works. We're only comparing by the first thing in the tuple. I think that's good. This is now called ins. Nice. That appears to have worked. I is actually called index, because otherwise it was a confusing name. Beautiful. Functions and offsets. Iterated. Okay, so for some reason we have like a unit type here. Because we just need to say functions and... I forgot. So this needs to be made mutable. This doesn't return anything. This is a sort in place. So we just... if we assign from this function, we get a unit, because that makes sense. That makes a lot of sense. Okay, so neg is not implemented for u32. Let's make it an i32, and we'll say we'll turn it back into an i32, and we'll test this as an i32, and we just say the number won't get that big. Offsets are, oops. That's the one I meant. Okay, cool. Expected i32 found usize. Let's turn u into a usize. Oh yeah, and let's forget the type of this as well, because that's actually not really relevant. That's causing issues. Expected u32 found usize. Okay, so now we're getting into the meat of it. Does -1 mean there isn't one yet? Yeah, this is a good point, 6 dBW. Why am I writing -1 to mean there isn't one yet when I literally have the power of Rust? Let's make it an option U32. Yeah, that's so silly. I don't know why I was doing it this way. Thank you for calling that to my attention. I've been writing languages other than Rust, and it's funny how corruptible I am. So what do I want? Yes, literally, I've been writing C the last week, and you just do weird jank stuff. So, if let sum O equals max offset, then we do this. Then we say if offset greater than O, we set this. Else, yes, I missed a thing. Otherwise, we just say this by default. There's probably a smarter way of doing this, right? But that's okay. We'll see if Clippy recommends anything. This is like less elegant in a sense, but also very elegant in a sense. Sum offset. Cool. So now we'll say we'll just unwrap it. I think we still have to cast it to a usize. Unwrap. Because if we don't have any code, we're just going to blow up, and that's bad. Index. Expected U32 found usize. Okay, so index usize. As usize. Can I just cast it to a usize? It's hard because some things are U32s because that's internal to the machine, and I'm not sure where I should be converting them to the outside world, other types. Okay, now, this iterator, we need to go, I think I need to do that. I need to make it a borrow iterator. Nice. We also now offset, we need to do this deref, we need to do this deref, we need to do this deref. Beautiful, now we're building. So let's copy this again, and it's gonna work. Okay, we broke something. The length is 0, but the index is also 0. And that makes me go, 6 dBW, thank you very much for the follow, thank you very much for the code review. You know, my Rust code is good because my wonderful audience helped me on my journey, and it's really helped me a lot learning a new language that is very complicated. So I really do appreciate it so much. Thank you. Let code size equal max offset unwrap. It's possible that my comparator is minimizing instead of maximizing, maybe. Actually, wait, I don't need to sort anymore, do I? That was the point of... So, do I sort and loop twice, or do I just... I get rid of the sort. The sort's stupid. That was very, very silly of me. I'm doubling up. My brain's failing me. So, we'll do this calculation plus max offset func size, and we need this to be a usize. And then we say with capacity this code size. But let's also trace log it out, pre-allocating code. I don't know if I have trace imported, and that's okay. Use log trace. Log, is that not correct? I don't think I include log until my other branch. That's not right. Lang cargo toml. Yeah, I don't have any logging until my other branch. Huh. Well, we'll deal with that later. Mutable. Functions and offsets doesn't need to be mutable because we don't sort it anymore. Nice. That's good. Main panicked. Length is 0, index is 1. Why don't we get any print? We should print something out, right? Because that's on line 228, which is after this. Do we not print when we have a panic? Let's also do it. Let's also do something here and say, let's do it here. Let's do it like this. We have proper logging in another branch. We'll fix this later. The famous last words. How big is raw instructions? So raw instruction is one U16. The number of instructions can be bigger, but they're not huge. It's a fairly small virtual machine. If you have a suggestion for doing this cleaner, I would love it. I would love to see it, because I know there's a better way. Somewhere in my soul, something's telling me there's a better way to do this. I just don't know it. So what am I doing? New max. And I put the debug printer there because it's a option, and I don't know what option does when you try and print them out. Code size not found in the scope. Yeah, because that doesn't make sense. I copied stupidly. Oh, hold on. Well, of course it's not printing anything because I'm piping the output. There we go. Reallocating code space for 17 bytes. I don't know if that's correct. I suspect we never find a new max. Okay, let me else. Offset less. O. 0. Yes, good. Okay, so here's the problem. We never set the offset. So what we need to do is say block offset equals program offset. Now it's going to do something. And this just has to be mutable, that's okay. Except we're cloning this, we're not actually mutating it. So can I change it? No, because this mutates. I see why this happened like this. I see why we did it this way. I see the conundrum. Oh dear. So I guess we just do this in 2 steps. For block and ctx functions clone. This is very inefficient. But we'll survive. We do another loop, but here we don't clone, we just like borrow it. Can I do that? No, I've got, this isn't how I do it. I want iter mut. I want dot iter mut. Like that. So now we could do offsets correctly, and that's good. And these are all multiples of, do I want to mutate context functions? Yeah, I want to mutate context functions, but the problem is that context.functions, I also want to mutate context from inside of there, and that was a weird like borrow loop. So you just do it in 2 steps, that's okay. It's less efficient. I can untangle this eventually. It's weird. My data, it's kind of grown from the inside, and I've had to mutate things in a few places that I didn't originally plan for, and Rust makes that kind of painful. So I've solved that by doing things in more steps to minimize the amount of writes in any given step, and that has allowed me to not get stuck in borrow checker hell too often. I've still gotten stuck in borrow checker hell, but I can identify the kind of thing, like I can sense it coming, and I can tell when I just need to move something out. This is true. This is true. It takes the whole context. It doesn't need the whole context. Partial borrowing, clearer data dependencies between the fields of context would resolve this. But for now, this is adequate. That would turn into a different problem because there's more cleanup in this whole thing. It's a classic thing to run into. Yeah, I have found the stupidest possible solution. My approach for all the Rust code I've written is to approach every problem with the stupidest solution that works, and then to iterate on it. And I've gotten a whole programming language out of that, so that's pretty good. So I'm pretty happy with that. I'm pretty happy with that approach. And this will do for now. Cool, so what's the next thing? We're pre-allocating space for 546 bytes. Now, I realize what I've done wrong. This one's actually really easy. And I've made this mistake. I know because I made this mistake in Go many times. I've made a vector with capacity, but not a vector with size. There's a difference. Capacity just means that when we add to the length, it is pre-allocated so it doesn't have to grow. So I want a vec with size, with capacity. Can I Rust vec with size? I guess the other thing I could do is use the macro, and I could say vec 0 code size. I think that will do it. I think that makes sense. Cool. So now we actually have a vector with filled with zeros. Nice, nice. That's really good. Let's get rid of that. Let's get rid of these printlns temporarily. We don't need this else anymore. That's very redundant. To do replace with logging. That would be useful. Yeah, vec 0 len. I always forget the :len part of that macro, but it's good. It's a really useful macro. Very top tier macro. Okay, so now we have a binary, and let's base enc base 64 URL. Let's grab it on our clipboard and put it into our visualizer. And let's see. Something went wrong. Oh no, not code 1C. Okay, we broke it. We broke it in a non-obvious way. That's excellent. That's phenomenal. We have a lot of zeros in here. A lot of zeros. 1, 2, 3. Maybe more zeros than I would expect, given that I should be padding 16. Actually, hold on. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Well, I can kind of work it out, right? So 75. So 256 is a multiple of 16. That's correct. But I think there's another one between 75 and 256. These numbers are, 70 apart, 80 apart. So there's a couple of multiple of 16s in between that we're missing. So that's kind of stupid. I guess it's not the end of the world, but it's kind of stupid. 75, 76. I also worry, I guess there's a few instructions that have an entire least significant byte of 0. That's okay. Maybe I need to modify this to actually tell me, oh no, so 16832. So we can code instruction to text. We probably can rerun this and work out exactly where this has gone wrong. This is indeed some code. Yet int 0 memory. This is not exactly the code that I wrote. Something's being processed here, which is a bit strange. A bit unusual. R3. If R3. Huh? What? Code to instruction text. Code to instruction text. I guess this is in my WASM, right? Code to instruction text. Okay. Instruction paths, try from, format, instruction paths, index offset, instruction. Now I should have I have an offset as well, right? I do. So raw instruction at index times 2 plus offset. I think those brackets are an artifact of a cast, but I also kind of like extra brackets because they make things clear. Okay, let's make WASM. Haven't done that for a while. Cool. Okay, now I need to copy these into the thing. So I'm just going to quickly copy www package star. We're going to put this in home, workspace, web, learn simple VM, public, package. Yeah, here. We're going to override them. Okay, cool. So now when we reload, we're going to get a better error. Maybe? Hello? VM not initialized. Setup. It broke. What broke? Preload program. Why did it break? Load binary. Load binary broke. What broke? Why are you broken? Let's do this. Do this. Do that. What? Why aren't you hitting this? Let me... I don't want this to turn into a WASM stream. Let me reload the dev server. That's always worth doing. VM not initialized. Why not? App.view 95. Yeah. Okay, so this is fine. This is fine. This is fine. If load binary is a function, well, this is fine. Parse binary, get section 0, log it out, good. Get program text, error. Okay, at 144. There we go. That's it. That's all I needed. That's all I needed. Now how do I look at what 144 is, because I can't load the binary into my tool because it doesn't know what it is. I didn't think of that. Hold on, I have a disassembler. I have another disassembler, but well, 144. So this all gets dumped out. This all gets dumped out, right? This is the entire thing. This whole section, read only address 26, file offset 58. File offset 58. So it starts like partway in. 58. Okay. Okay. Address 26. Address 26. Offset 58. Address 0, file offset 64. So this is our static data. This is our heap. And this is our... So, file offset 58. So it starts at address 58, I guess. Maybe. Maybe this is just that section. I can't quite remember. Maybe it's the whole thing. Okay, so we have a lot of zeros, and then we have stuff. And it looks like we're over padding, but that's okay. We're not afraid of over padding. And this said was at 144. 144. But it's not 144. It's index times 2 plus... No, it is. 144. Index times 2 plus offset. Index times 2. Number of instructions. So this is in bytes. So it is actually 144. 6567. Opcodes 1C. I swear I've seen this before. 6567. So let's do that. Let's do that in Python. A equals 65, B equals 67. So the least significant byte is A. So let's say C is A plus B left shift 8. Also, this should be the same as hex. So this should be hex 43. 41, sorry, and this should be hex 43, which it is because it's 2 apart. So 4341. Okay, that's good. That's good. Where does 1C come from? Where'd I get 1C? 144. 1C. Offset. Offset. What's 1C? 28. Is there a 28 anywhere? 28. 28. I want the number 28. Oh yeah, interesting. Yeah, file offset. Hold on. This doesn't factor in the header. This does not factor in the header. So let's open a new buffer. Let's paste this in. Now, Vim, if I can replace with a new line, I can get them all in different lines, then I'll have the entire binary with each byte on a line. There you go. This, but with perfect. Okay, so this is the entire binary, right? The whole header and everything. And if I look for 28, there's no 28s. Okay, so raw instruction, ins in the instruction pass, try from raw instruction. Okay. Okay, I think I'm going to leave it there for today. This has been a fun and uplifting stream, but I want to try and get to bed a bit earlier tonight. I've had a busy day, and I don't think I have the brain power to work out what this is right now, but I've literally seen this error before, and that makes me nervous, and it makes me think it's not anything obvious. I got to dig into this and work out why the alignment's broken. But once I fix this, I'm going to do a cool git rebase, probably next stream. I'm probably going to fix this off camera and then do a cool git rebase on stream, because I think rebase is cool and I think people should see the workflow. It's really useful. So let's find someone cool to raid. If you have any suggestions for someone to raid, I'm always happy to take them. I'm always happy to share the love around with other cool streamers doing cool stuff. And for everyone who's been following along on YouTube, as always, I say this at the end of every stream, I see there's a few of you watching to the end. Thank you so much. It really means a lot to me that people care. Where and game, that's not what I wanted. Category is software and game development. Let's find someone doing software and game dev and having fun with it and share the love with them. Code jamming. Working on a stream manager, that's kind of fun. Debugging the matrix, taming AI gremlins in Unreal 5, that's kind of cool. Super Mario 64 like game, that's kind of fun. C# Godot, making a game, maybe. That's kind of cool. Colombian. Hopefully someone English. It's hard to find. Lots of the English streamers I know do not stream at this time for various reasons. You know, I mean, this is, what is this? Is this operating system development? It looks like it is. No, it is not. Finding someone to raid's hard. It really, it's like they've got to be the right size. They can't be too big. They can't be too small. They can be too small. But you know, you don't want to raid someone too much bigger than you. But also, not many people. Here we go. Rust game engine. Game engine. Let's do it. Let's see what this person's up to. Raid away. Throw on the Rust love, the Rust train coming through. This has been a very fun stream. Thank you everyone who's been hanging out. I'm Tom. 6DBW. It was wonderful to meet you. Thank you for your Rust advice. I appreciate it greatly. And let's go share our Rust love with someone else. So be sure to tune in again in the future. I'm Tom. I will catch you next time. Bye.